Hello everyone, this is a live stream Operations Management Week 2, Lecture 2. And the second lecture this week is looking at the homework. And I do have a chat room for those who would like to ask any questions, just like a lecture. And then I'm just going to go over the homework. Now I'm not going to go all the way through and give all the answers to the homework, but I'll show where to find the material to answer the questions, how to set up the materials, things to watch out for when you work some of the problems. And what we'll look at here in this introduction, this second week, the definitions of terms, is going to be the at the beginning of definitions and also the break-even analysis. Now, let's bring up Canvas, the website. And if we come down to the schedule, here we are, the second week, week 2, and we are looking at the definitions. Now next week we'll do the quality control, and homework 1 is not really due until September 6th. It's not this Sunday, but it's the next Sunday. And so notice I've spread these out 2 weeks on each one of these. So I want to have plenty of support. I'll cover these things in a lot of detail so everyone can understand operations well, because these days, today, operations is really important because they're being challenged in almost every industry. Okay, so that's what we're doing today. The definitions of terms and the break-even analysis. So let's bring up Canvas. And in Canvas, when you look down here, here we are in week 2 and 3. And here is the lecture that I had on Monday, week 2, lecture 1. And then the second lecture, this lecture will be a video, and it'll be posted here as a link, and you can watch it. And this goes right to my YouTube channel, and you can see my other channels. But to look at the lecture material up here, go to my website, mdharper.com, under Operations Management tab, and you come down here. The introduction video right here, this introduction to operations, this is the video that I'll look at today. The Excel file here, the break-even analysis Excel file, is what you can use for today. And so this video and this Excel file will help for what you're doing today because it's already set up for you. Okay? And I would highly encourage you to watch this video because it does go through all the definitions. I went through it on Monday in the lecture, but this video has more illustrations than my lecture. The video is more as a presentation. My lecture is more of an explanation in a lecture, but the break-even analysis, this Excel, is how you solve it. You can see the equations in there. And so from the video and my lecture, you can see exactly how to work it. And this is what I'm going to be doing today. Okay. So let's minimize this. Let's bring up the homework. Well, if you go back to Canvas, and come down here. Here's homework number 1. Let's just download this. This is what I'm looking at. Download, you click it, and it downloads. And I'm going to open this up, enable editing, full screen this, and let's enlarge it. Okay, and so this is what we're covering today. Okay, homework number 1. Here we go. We're getting going here in the second week. I talk about the instructions. Make sure that you get all the answers before you submit it, because you can only submit it one time and there's no answers. It's just A, B, C, D, E. It's multiple choice. And so get all the answers before you go into Canvas. The support for this material is on my website under Operations Management tab. And even on the questions here, part 1, I say use video 1 under the introduction heading. I just showed you where that was. Now this first question, actually these first 2 questions, if you notice, the application of input-output process depends on type of industry, which includes continuous, intermittent, and service industries. Within the descriptions of the type of industries, how many statements are true? And that first video will go through each one of these in detail. Not only that, if you look at the red book, in the red book here, I went over this. I kind of explained it, but the video actually gives examples of each one of these, okay, in a fair amount of detail. Okay, then the second question, an operation strategy. Well, if you bring back the red book, let's bring back the red book. Notice I first talk about the input-output model, question 1. Question 2 comes down here on the operation strategy. Now, on this terminology, the terminology is important. This is product design, process design, and there's two types, manufacturing process design and service process design. And then inventory, finished goods inventory, or inventory design. These are designs, and these decisions, which are strategies, these are strategies within that design which defines the strategy. Okay, these different decisions within each of these process designs will identify your strategy. So the questions come from this description on Monday, but also again in the video I describe these in much more detail. Okay, and so there's where these come in. Operation strategy is defined as a series of decisions within different design groups. These are the design groups. That leads to an operations management objective. The design groups are these. Within the descriptions of operation strategy, which I gave in the lecture, and the red book, and the video, how many of these statements are true? And I'm just matching these things up. And so you just match them up and see how many are correct and how many are not correct. Okay, part 2, now I get into the break-even analysis and I get into Excel. And notice use video 1 and Excel under the introduction heading. I've already showed you where that was. Okay, and here's a problem, a simple problem. A local company is considering 3 options in meeting demand. Option 1 requires no fixed cost and purchases the product from a supplier for $1. In other words, you just buy it straight out, like a spot price. Okay, so that's option 1. The other options consist of producing the product in-house at a reduced variable cost. Well, if you're producing it in-house, usually it's cheaper to produce, but there's a fixed cost to set it up to produce it. Okay, option 2 has an annual fixed cost of $280, but a reduced variable cost of 50 cents per product, from $1 down to 50 cents, half as much. Option 3 has a higher annual fixed cost of $610, but a variable cost of 20 cents for each product. So this is really common. If you spend more money, you can usually have a more efficient operation, but sometimes it takes longer to make that money back, or you can make it back sooner. Depends on the fixed cost and the variable cost. And there's where break-even comes in, and there's where the analysis comes in. Well, what is the break-even between options 1 and 2? Okay, well, remember, tell you what, let's do. Let's go to the website, and let's download the break-even analysis. Let's open this Excel file. And one thing I'll just mention as I open this file, that we'll be using Excel quite a bit at the beginning of this course, and a lot of what we're doing you will need Excel, okay, especially in the optimization. But later you can do it by hand, and I designed the exams where you don't have to use Excel. You can't use Excel, and you don't need to use Excel. Okay, here we go. Now notice when this Excel file that you download from the website, and notice these right here's the bar. These are typed in. Okay, all these are typed in. These are different numbers. This is from the red book. Okay, and this tells you what the equation is. Okay, but over here, let's see here. Before I get into this, do we need the red book only to answer question 2, or can we also look in the book? Oh, I think in the syllabus I say you can only use a red book and that's all, no other material. But if you want to use the textbook, you can. When I say the red book only, usually when I have a classroom, I just want a textbook. But online, if you have a textbook and the red book and the textbook, that's okay. But I've designed, and you'll see, I've designed the exams to where the red book is all you really need. If you have the textbook, it could be more confusing, and I would recommend to everyone take notes in the red book and have that red book as like a study guide. Have that red book as a resource, as a manual. This is the material I need to know. Okay. Now back to this here. You see in this cell here, you can see what the equations are. Okay. And notice what I do here. C3 minus C5. C3, the fixed cost minus this fixed cost, right? The blue minus the red. You take the difference of the fixed cost and then you divide it by the difference of the variable cost, but you reverse it. And remember I said the pattern, if the fixed cost goes down as the variable costs go up, that pattern indicates a break even. Well, here's how you get the break even. You take the difference of the fixed cost and difference of the variable cost, but you do it inversely. In other words, the higher minus the lower divided by the second one minus the upper one, the higher minus the lower. And that's a break even. That's how you calculate it. Okay, and so I'm not going to do it with your numbers, but that's how you do it. Okay? Then down here's how you plot it. You don't need to plot it in this course unless you want to, but that's how you plot it. Okay, let's get back to the homework. What's the break even? For a demand of 1,000, which option has the lowest cost? So for question 4, what I want you to do, let's come back, let's bring the Excel back. What I want you to do here is when you have a demand, let's use this, and let's just create another one here. When you have a demand here, okay, let's say your demand equals 1,000. What I'm asking you to do here is actually calculate the cost, which is going to equal the fixed cost plus the variable cost times 1,000. Okay, for the automated. And then I can copy this down for the cellular. In this case, see, what am I asking? I say which cost, which has the lowest cost. Well, this is not your problem. This is the problem. Well, you see that number there is lower than that number. That's all I'm asking. Okay, all I want you to do is understand what the fixed and variable costs really mean. Okay, that's all I'm getting at here. How many statements are true? Well, option 1 has the lowest cost for demand of here, here, here. So I do this for 1,000, but then I want you to do it for different ones because I want you to compare that with the different options and see which one is lowest. So this one is comparing these options, okay, for a demand. This is doing all the options, and so it's doing the very same question, but I'm doing it not, say, here's the demand, which option is lowest. Here I'm saying which option is lowest for all these demands. So I just kind of reversed it. Okay, so that's this first one, number 2 here. And that's just an introduction. Okay, part 3, 6 through 8. Now this is a little bit deeper, not much, but a little bit deeper into a practical problem. And this one, again, it's video 1 in Excel. A company is examining the cost of producing an item in-house rather than purchasing it from a third-party supplier for $79.50. In-house production would require one-time purchase of equipment of $2,100, but the in-house production would cost only $450 per item. So now we're doing just in-house, we're doing just one, and then when do you get payback? Well, payback means how long does it take to save up between these, to save up the $2,100. But notice the demand for the item is a constant 10 items per week, where 1 year is 52 weeks. So I put a little bit of a practical sentence in here. So we're talking about break-even. You can talk about break-even in your demand, but it's more likely to say my break-even is this amount of time. It's 1 week, 2 weeks, 10 weeks, 1 month, 2 months, 3 years, 10 years. When's your payback? When is your break-even or payback? Okay, what is the break-even in weeks? Okay, now be careful here. A lot of people have trouble, or they overlook this. They don't have trouble. They just overlook it. So be careful in weeks. I'm not talking about how many items. I'm talking about weeks. When the cost of the in-house option is equal to the cost of the outsource option to the third party. Well, when those costs are equal, then that defines break-even. Okay. So when I say what is the break-even in weeks, and then I actually say what the break-even means, okay? I could have stopped right there and said, what's the break-even in weeks between in-house and outsource? I could have said that, but I didn't. Okay, you do it again. Let's do this again. Let's bring up Excel again. Same thing here. But this time we only have one, okay? And by the way, I don't know if you noticed this or not. Let me go ahead and delete this. Alt-ED and deletes. Let me go ahead and look at this again and say, you can download this and you can look at this sheet. I don't know what these other sheets are. Oh, I'm developing this, blah, 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 blah. And then I graph it. You can download this and then put these numbers in here, because the equations are already there. You don't even have to develop. This is a template you can use. Yeah, make it easier on yourself, you know. Well, make sure you know how to do it. This is how you do it. And so you just put these numbers in here. So the fixed cost is 0. See, what is it? So in-house, let's say this is in-house, and this would be 2,100, and this is 450. This is third-party outsourced, and that's going to be 0, and then that's going to be 7,950. You can just type those numbers in there, and it'll give you the break-even production in the production that's break-even. Okay, but notice I'm asking what's the break-even in weeks, not production. So let me ask you, if the demand is 10 items a week, and I don't know what the break-even is, but let's suppose the break-even was what if the break-even was I don't know, 120 items. Suppose the break-even was 120 items, but if the demand is 10 items a week, then what's the break-even in weeks? 120 items equals how many weeks if the demand is 10 items a week? Well, it's 120 over 10, which would be 12. So notice I'm asking about weeks here, not production items or demand items. Okay, so be careful. What's the total cost of the in-house after 2 weeks? Well, after 2 weeks, what's the demand? 20. Okay, so the same as before. Let's come back to here. Like we did before. I've already I deleted it. Okay. A demand equals, let me say production. Demand production equals. So how much was it again? 2 weeks. 2 weeks. Well, if it's 10 items a week, what's the production going to be in 2 weeks? In other words, you're producing to meet demand. It's going to be 20. And so you do 20 and put it in here, okay? And then calculate whatever the costs are, whatever. I think, what am I asking? Of the in-house. So the in-house, how long is that going to, what's that going to be? Okay, then 8 here. Let's get this out of the way. 8 here says, oh, after 6 months, what's the difference in cost between the in-house and outsourced? The difference in cost between them. Okay. Oh, and also, I noticed when I first opened it up, I think someone may have mentioned this, but I noticed it. I don't know if they mentioned it last time or whatever. But notice A says more than. It's the same number, but it's more than. And the in-house is the same number, less than. Now, I think when I first opened the homework assignment, more than was less. So I had A and D the same. I didn't want that. So I had A is going to be more than, D is going to be less than, and this one is a different number. That's a different number. So now I have 4 distinct answers and then none of the above. Okay. Anyway, 6 months. So what's the demand going to be? 10 items. Okay. If you have 6 months is half a year. 52 weeks in a year, half of 52 is 26. 26 weeks. So if it's 26 weeks, what's the demand? 26 times 10 is 260. So then what you're going to do is this will be the production is 260. Because that's 26 weeks, 10 items a week. Okay? Okay. Caroline, question 7, answers have the same number appeared twice, A and C. A is 28, C is 7. Oh, you're right. You're right. Okay. Yep. Well, I don't know what the answer is, but if if 2109 is the answer, then I'll count both of them. So it doesn't matter which one you answer. So therefore, wouldn't it be nice? No, I'm going to say that. I'm not going to say it. But what I was going to say, wouldn't it be nice if all the answers were the same and you have to pick something and you're going to be right? Anyway, let's see. Question. This is homework 1. I'm going to make sure that whatever if 2190 is the answer, if you pick A or C, they're both going to be right. Now I have to do that by hand in Canvas. So once I open it up next Monday, it takes me a while to do it by hand on all the values. But no problem. I'll do that. Homework 1, question 7. Thanks, Caroline. Let's see. A and C, same answer. Now, I don't know if that is the answer. If it is, then both are right. If it's not, then either B, D, or E is the right answer, and then that'll be the answer. Then there's only one answer. But I'll watch that. Okay? And it actually brings up a very good point. I didn't mean to do this. It was an accident. Somehow, when I put these numbers together, I probably had another number there. I didn't put it in because it was an error. But the point is, if I do make an error like this, then I'll say, oh, that's an error. If that's the right answer, both are right. You're going to get it. Okay? If it's not the right answer, then one of the others is right. But sometimes I do put 2 right answers, and the reason I do that is to challenge the thinking to say, I'm sure this is right, I'm going to answer it. Because sometimes they'll say, oh, 2 answers, oh, well, that can't be the right answer. I'll say no. Well, that's the wrong thinking. If it's right, it's right. It doesn't matter which one is right, they're both right. Sometimes you'll have more than one right answer. Okay? And sometimes I emphasize that, I didn't do it this time, but sometimes I do. Okay. One time, and I'm almost done here, but for example, multiple choice. I've had students tell me, you can only have one right answer in multiple choice. No, that's not true. Yeah, but this is a mistake. That's true. But you can have more than one right answer. He says, no, that's not true. I says, yeah, it is. Talking to another instructor, and I go, yeah, it's true. He says, no, I said, I teach quantitative multiple choice. You can't do that. It says, yes, I can. For example, which number is greater than 5? A is 1, B is 2, C is 7, D is 8, E is none of the above. What's the right answer? They say, oh, none of the above. No, C and D are right. 7 and 8 are greater than 5. Yes, but one of them is not. No, both of them are. So they're both right. So just pick one, okay? So if you say none of the above, you're telling me that 7 and 8 are not greater than 5. Okay, I find that interesting. I find that fun. It's exciting, okay? And go, yeah, oh, okay, so it's interesting math. 7 is less than 5. 8 is less than 5. Says, no. So, well, you said it was. I said, wait a minute. No, what I meant was, I know what you meant, but be careful when you say things because people will take you literally sometimes. Okay? So, I don't do that here, but sometimes I do. But if I do, I'll do it with a purpose. And the purpose is to learn, to teach. For example, one more story, then I'll stop. Some of these problems will be working in operations. There's different approaches that you can take. And both of these answers are right, but one is more of a certain type of strategic approach. The other is another strategic approach, and the way the problem is stated, both will solve it, but they'll solve it in two different ways. And both are correct the way it's posed. Okay? And actually, in the real world, there's a lot more than one way to do things. And there's a lot more than one way to have an optimal answer, a correct answer. There's more than one right answers. And I want to emphasize that. Okay, and that's the kind of thing you probably should be learning at a university, to think much broader and not just about the exams or the homework. Think about what these things mean. Okay, so I'll try. Hopefully we'll work together, and I'm going to try to teach as much as I can of what I know. And so actually the 9 and 10 down here is going to be statistics. I'm going to cover that next week. I'll do the mechanics here, and then here's going to be qualitative. I'll do both of these next week. Okay. This is all I'm doing today. This will be rendered as a video and put on my website. And I just want to go nice and deliberate, I hope, this course. Now, let me bring up the syllabus before we leave. So each one of these, I have very specific things every week to cover. Okay. But when we get into these here, some of these, like aggregate planning, it's going to be a lot of material there, and so we'll probably need 2 weeks. We don't need 2 weeks on this, but we probably will, beginning forecasting, aggregate planning, inventory. Okay, and so now we're getting deeper and deeper and deeper. Okay, so let's start a routine and get this routine going and get used to it. That's all I have for today. So we have office hours on Friday at 7 p.m. And it'll be the link is on Canvas. Just make sure everyone knows where all this stuff is. This is Canvas. There's the link for the Zoom for office hours. And down here, right here, there's find Zoom link, office hours at 7 right there. You click that, it's a Zoom, and it's just for office hours. I have no agenda. It won't be recorded. We'll just a conversation. So, I hope this helps. How to work these things. That's all I have to do. That's all I have today. And so between now and Friday, and actually this summer, this fall, I just want to encourage everyone to be careful, be safe. Don't take anything for granted. It's not worth it. Stay healthy. So that you can focus and learn as much as you can in the time we have, because this is an opportunity. Don't let anything jeopardize it. So just be careful. Don't take anything for granted. Okay. So until next time we meet, take care.